Our focus today is the continuation of what we discussed during the last time regarding the hypothesis testing. So in here, in the process of hypothesis testing, we have four steps, and the number four step or the last step in there is making a decision. Okay. So before we go, before we're going to start this discussion, now may I again encourage everyone to please support this channel by clicking the subscribe button, okay? And of course, by clicking share button to your classmate and to your schoolmate or friends so that they can also understand the lesson if they are taking the subject statistics, especially the hypothesis testing, okay? Now, in summary of the hypothesis testing, you notice that when we are going to have a research, of course, when we are going to make the inquiry now regarding the hypothesis, we have at least four steps. So in the step number one, we have the statement of the hypothesis. A researcher states a null hypothesis about the population and an alternative hypothesis that contradicts the null hypothesis. That is the step number one, and we have said that the step number one is actually the starting point of the inquiry. Number two, set the criteria for a decision. A criterion is set upon which a researcher will decide whether to retain or reject the stated null hypothesis. Okay? A sample is selected from the population and the sample mean is measured. Now notice that after setting the criterion, we will be moving on now to the step number three, wherein that is the compute or what that is the computation of the test statistic. It says in here, compute the test statistic. This will produce a value that can be compared to the criterion that was set before the sample was selected. And of course, for the step number four, after the computation, meaning to say we compare the p-value to the set criterion and make a decision. If the probability of obtaining a sample mean is less than 5%, when the null is true, then reject the null hypothesis. If the probability of obtaining sample mean is greater than 5% when the null is true, then retain the null hypothesis. Now our focus in here is actually the step number four. Okay, so let's try to start. So making a decision. So when we make decision, we have to consider types of error. Okay, we have to consider type of errors. So it says in here, when we decide, the decision to retain the null hypothesis could be correct, and that is true. Or another one, the decision to retain the null hypothesis could be incorrect also. Okay, so meaning to say, you can retain the null hypothesis that is considered to be correct. You can retain also the null hypothesis, but that could be incorrect. Another one is the decision to reject the null hypothesis. Retain. What we are talking, the previous is retain. In here, rejection. The decision to reject the null hypothesis could also be correct. And we have another one, the decision to reject the null hypothesis could be incorrect. Now, so that these are the scenarios regarding the decision regarding the hypothesis that we stated in the step number one. There are times that we decide correctly. There are times that the researcher could decide incorrectly. Okay, incorrectly. Now notice that these four outcomes of making decision are put into table. Okay, so the reality in the population is that when we decide, uh, we might be retaining the null hypothesis, and another one, we might reject the null hypothesis. Now, when in the population it is true, the null hypothesis is true, okay, and we retain the null hypothesis, meaning to say uh, that could be the proper one. But when it so happened that the null hypothesis is true and you rejected the null hypothesis, that is considered to be a type 1 error. Okay? So again, when we are talking of the null hypothesis, there are two realities. We can be committing a correct one, decision, or incorrect decision. So that if the reality about the population is true and we retain the hypothesis, then there is no problem. Our decision is correct. But what about if the reality about the population which is true, we rejected that null hypothesis, meaning to say that is considered to be a type 1 error. So when we say type 1 error, you rejected a correct hypothesis. Again, when we say type 1 error, you actually rejected a true statement, a true null hypothesis. So that is considered to be a type 1 error. Now what about if in reality the null hypothesis about the population is false, and that you retain the null hypothesis, meaning to say this one, uh, the null hypothesis about the population is considered to be false, but you retain the null hypothesis. Now that error is considered to be a type 2 error, meaning to say you actually you actually accepted or retained the null hypothesis when in fact the null hypothesis about the population is false. Okay, about the population is false. Now what must be the proper if that is false? Now you have to reject when the null hypothesis about the population is false, you have to reject the null hypothesis, and so that must be the correct decision. Okay, that must be the correct decision. So these are the four outcomes regarding the decision of the stated null hypothesis. Okay, again, what are these? We consider type 1 error. When we say type 1 error, meaning to say we rejected the null hypothesis when in fact that null hypothesis about the population is true. So that is the type 1 error. Now what about the type 2 error? You rejected, or I said you retained the null hypothesis when the statement or the null hypothesis about the population really is false. Okay, really is false. Okay, so that is, or these are the four outcomes of making decision. So our focus in here is the type 1 and type 2 error. Okay? The next thing that we're going to discuss is the level of significance. Okay, when we say the level of significance, this pertains to the criterion we set forth in the step number 2 of hypothesis testing, meaning to say this pertains to the alpha level. Okay, alpha level. Okay, now what is meant by alpha level in the level of significance? It is actually the level of significance or criterion for the hypothesis testing. It is the largest probability of committing type 1 error that we will allow and still decide to reject the null hypothesis. So that is the meaning of the level of significance. Now, it says even in here, it is the criterion usually set at A is equal to 5% or alpha level is equal to 0.05, and we compare this alpha level to p-value. A p-value is the actual computed test statistic. Thus, when the p-value is less than the criterion, we decide to reject the null hypothesis. So that is the meaning of the level of significance. Now, two types of errors. We have already presented this one using the table. Now, when we say type 1 error, it occurs when the null hypothesis is rejected. Okay? It occurs when the null hypothesis is rejected when it is true. This is when the null hypothesis is wrongly rejected, meaning to say, when it was established that the null hypothesis is really true, and that you rejected this null hypothesis when in fact it is true, then that is called to be type 1 error. Okay, type 1 error. Since we assume the null hypothesis, the researcher directly controls, okay, or control for the probability of committing type of error. Okay, this type of error. Now, notice that when we are going to have the example, it says in here, Saddam insisted that she is 30 years old. This is a lady. Saddam insists that she is 30 years old when in fact she is 32 years old, meaning to say it was established that she is 32 years old, but she insisted that she is 30 years old. Now she is committing type 1 error. Okay, so that is the example. Another one would be Bin Laden says, this is a boy, Bin Laden says that he is not a bald, but his his hairline is just receding. Now, notice that in fact, his hairline is receding when the hairline is actually is a part of baldness. Okay, so he is committing a type 1 error. Okay, so that is the meaning of type 1 error. It was established, in fact, it is true that that is the scenario, but in your decision you tend to reject the true statement. So that is the meaning of the type 1 error. Okay, so another one in here is type 2 error. It says in here, it occurs when the null hypothesis is not rejected when it is in fact a false, meaning to say the null hypothesis is really a false statement, but you did not reject that statement. So that is the meaning of the type 2 error. For example, a man plans go hunting the Philippine monkey eating eagle, believing that it is a proof of his mettle. Now in here, he is committing a type 2 error. Why? Because he believes that it is not unlawful to go hunting this kind of species, Philippine monkey eating eagle. So why type 2 error? Because hunting Philippine monkey eating eagle is against the law. The hunter may find himself in jail if he goes out of his way hunting endangered species. That is the very reason why that is considered to be a type 2 error. Okay? Type 2 error. Now, we have in here another term, power of decision making. What do we mean when we say power of decision making? It says in here, the power in hypothesis testing is a probability of rejecting a false hypothesis. Okay? The power in the hypothesis testing is the probability of rejecting the false null hypothesis. Specifically, it is the probability that randomly selected sample will show that null hypothesis is false when the null hypothesis is indeed false. Okay, so that is the meaning of the power of decision making. Meaning to say, you are really rejecting a null hypothesis when it's really a false statement. Okay, so power of decision making, specifically or in relation to the hypothesis. Okay. Another one in here is deciding with normal curve. Okay, so let's try to consider the different curves in the decision making. So in the decision making, we have in here the curve, okay, the normal curve, and this curve is considered to be one-tailed curve, okay? One-tailed curve. And the unshaded part is considered actually, or it is actually the area or the probability of the acceptance region. Okay, acceptance region, meaning to say acceptance of the null hypothesis. The shaded part is actually the rejection region. Okay, the shaded part is the rejection region. So this is one-tailed test. Okay, one-tailed test to the left side. Okay, so the next curve is actually a one-tailed curve. Okay, the yellow part, okay, yellow part of the curve is the acceptance region, and of course the part of the curve that is shaded with red is the rejection region. Okay, so one-tailed curve. Okay, and now let's try to have another one would be when we are talking of the decision making regarding our null hypothesis. The testing could be considered to be a two-tailed test. Okay, so in here I have the curve, the unshaded part again, which is we have in here the unshaded part is considered to be the non-rejection region. The shaded part with the two, okay, two-tail, the two extremities, the left and the right, that is actually the rejection region of the null hypothesis. Now notice that the boundary between the shaded part and the unshaded one, which is this one, this is actually the critical value, okay, the location of the critical value, and this one. Okay, so meaning to say, when we are talking of the probability of retaining the null hypothesis, shall we say the level of significance is 5%, the probability of retaining the null hypothesis is 95% and below. Okay, 95% and below. So that is located in here. Okay, and what about if the level of significance is 5% and that is two-tailed? The 5% must be divided into two. So meaning the rejection region located at the right is 2.5% and to the left is 2.5%. So that is the normal curve or the two-tailed illustration of the two-tailed test regarding the null hypothesis or testing of the null hypothesis. Okay, so again, let's go over. The unshaded part is considered to be the acceptance region or non-rejection region. The shaded part with the red, that is considered to be the rejection region. Okay, rejection region. Now what about the boundary between the red and then the unshaded part? Here they are called to be at the location of the critical value. Okay, critical value. Okay, so that is the normal curve. Okay, illustrating the normal curve of the hypothesis. Okay, especially the null hypothesis. Now we have another one in here, another curve. Okay, I already presented this one just to make a summary of the curve. So let's try to have the unshaded part is that is failing to reject the null hypothesis. If you fail to reject the null hypothesis, that is considered to be the acceptance region. Okay, now what about this one? Okay, the part of the curve that is shaded with red, so left and right, they're called to be the rejection region. Okay, now what about this boundary? That is actually the critical value. Okay, critical value. Now when we say critical value, these are actually the value of the z-score or t-score. Okay, critical value, the value of z-score or critical t-score, I should say, t-score. Okay, so again, these are the things that we need to remember when we are going to make a decision regarding the null hypothesis. Thank you and more power.